Solve this Leetcode problem to sum. It is a very well-known problem and asked in interview also. It's an easy problem. Let's see. So what is the problem statement? We are given an array of integers, uh, nums, and an integer target. So what we have to do? We have to return two indices, two numbers, such that they add up to the target, and we have to return the indexes of those two numbers, which will sum to add up to target. You may assume that each input would have exactly one solution. So it means they have given that there will always exist one solution only. Okay. You may not use the same element twice. Okay. So I mean the indexes which we are going to return, they both will be different one. They cannot be same. We cannot duplicate. So and you can return the answer in any order. Okay. A smaller one or bigger one, either of them can come first. So let's see an example here. So we are given this array and target is 9. So we have to find two numbers which will add up to 9, and then we have to return the indexes of those two numbers. Okay. So by looking at it, you can see like we have to find 9. So these two are bigger numbers, so obviously we are not going to use them. And 2 and 7, these are going to add up to give us 9. What are their indexes? So indexes are like 0, 1. So we have to return basically 0, 1. Okay, so it's a very simple problem. But now how we will approach this? How we are going to find these two numbers basically? So our first approach could be simple brute force approach. What we will do, we will simply traverse for each element. We will check for each element, we will check whether the complementary part is there or not. Basically, if this is 2, now what is the other number we want? We want 9 minus 2, which is 7. So we will check whether 7 is present in this array or not. Okay. So yeah. So now when we let's assume like 7 is not here. So then what we'll do, then for this 2 we will go and check for 11, then for 15. So simply if we have, let's see, 2, let's say we have 8, say we have 9, and we have 7 in the end. Or what we can do, 11, 15 to 7, like this we can have. So what we will do, firstly we will, for this 11 we will see, but we will check all the other elements after it, whether they can give us the answer or not. So we will check for 11, 15, 11, 2, 11, 7. So this is a brute force approach, like for each element we will check all other element. So for 15 we are going to check 2, then for 7, and finally we will check for 2, 7, where we will get our answer. So as you can tell, like since we are, for each element we are iterating twice here, so here you can simply say our, it is a n square complexity algorithm. Okay, so let's see its code here, Python code. So here I have just got the length of our array, and this loop will iterate the our array and choose the first element. Assume it like it is our first element, And for each of this first element, we are going to find our other element which can give us the sum. So, and here it is important to note we have given I plus 1. We don't want to check the previous element because those are already checked, all we have already checked them, right? So there is no point in checking them again. Okay, so and here is our condition. If we get the target, then we will simply return ing, and we know that the answer is there, answer will always exist, so this will never be reached. But still, like for better code representation, it is good to give this. Okay, so here you can see time complexity will be n square, and we are not using any array or something like that, so space complexity will be 1 only. Okay, so can we do better here? How we can optimize it? Because n square is like not considered a good uh, time complexity. So what if we are able to, for each element, what we are doing here, we are simply searching for the complementary part, right? So what if there is a way to search for the complementary part in O of 1, right? So now you have to think of like like in the previous example we were having 15 and something like this. So for this we were searching 7 in this whole sub array, right? And we have to traverse it, so we want to search the complementary part in O of 1. So now you can think of some data structures. uh, you have studied like we have map or set, and so those data structure are like good for searching purpose or storing memorization purpose. So what we can basically do is like for each element we will traverse each element and check whether whether we have the complementary part in our dictionary or not, right? So let's say we will create our dictionary, right? So firstly we are on 2, so we will check the complementary part 7 is there in our dictionary or not. So for initially our dictionary is empty, so there is no complementary part, so we'll go to the next. And yes, when we were on 2, we will store it in our dictionary, right? And how we are going to store? So we want the indexes basically, so we will store it like this, right? So this is telling currently in our dictionary we have a element 2 which is present in the array, and it is at the position 0. Now we will traverse to the next element 7. Now for 7 we want 2. Now we will search this 2. We want this 2 to get our final target. So we will simply in O of 1 we want to search, so we'll simply go and see our dictionary whether we have this or not. So it will say yes, you have 2 at the position 0. So you can simply return this 0 and our current index which is 1. So this will be our answer, right? So similarly in this way also, for each element we are able to search its counterpart in O of 1. So overall the time complexity is becoming O of n, right? So let's see the code. So here is the code. So this is like our dictionary in Python, how we can initiate an empty dictionary. And here I am traversing nums using enumerate function. What it returns? It returns index and value at the same time. So I don't have to like create the value later on myself, and right? So this helps in that. So now x is the complementary part which we want. Currently we are having a value v. We want target minus v in the whether we have reached this or not, right? So and we search this complementary part in our map, whether this element has already come in our map or not, right? If we have already got it, then we will return its position and the current position. Otherwise simply the current element we have to store in our map, right? So finally this part will again not be reached. We'll get the answer here only. So here you can see now there is only one for loop, right, which is traversing over our given array. So time complexity will be of n only. And space complexity, now since we are using our dictionary, so worst scenario we can say like all the elements we have to store, right? And also we have seen like each element will be stored only once here, like, so at max n elements you can save, right? So it is better than O of n square, right? There is also one two pointer approach, but here we have to return the indexes, so that's why not using that. Otherwise that could also be looked into, but then that approach will be n log n, but space complexity will be 1 in that algorithm. uh, but yeah, we can look it later. So this is it for now. Hope it clears it. Thank you.